me fill it here. All right, class. Weak sauce right there. Come on, Denny. All right, so we're gonna go through. This is the Calculus AB Section 2, Part A, 30 minutes for the 2 problems. But we're just going over this first question. So one question, we're gonna break it down in all its glory that we can. So we're given a table, and this table represents this, which is, if it says liters per hour, isn't that a rate of change? Yes, it is. That is a rate of change, right? So that's going to help me out, since that gives me a rate of change. So water is pumped in the tank. So there's water. So if I have a tank, and I have a water faucet. There you go. So water is going into the tank. Going pew, pew, pew. Okay, it's going into the tank. All right. So water's pumped into the tank is modeled by this. So we have 2 different equations here. We're modeling of the water in the tank. Liters per hour from 0 to 8 hours, where T is measured in hours. Water is removed from the tank at a rate modeled by R of T. That's what we have up here. Did it just stop on me? It did, didn't it? Joy. Okay. So it's coming out. So water's coming out also, modeled by this. R is R is differentiable by and decreasing from here to here. Selected values of R shown in table below. At T equals 0, there are 50,000 liters of water in the tank. So that's my starting amount. So estimate R prime of 2. Now, R prime means that is the derivative, right? So all I want to do is find the slope in between there and there. And that's going to give me my rate of change. So I am going to plug that in. So if I want 2, I'm going to use 1 and 3. I don't know why everything's got to be difficult. Today is Monday. So, anyway, it worked for like 2 seconds. Let's see if it worked. There you go. Okay, it's working again. There we go. There you go. Okay, so I'm going to use these 2 here to calculate the slope in between. So 950 minus 1190 over, it is 3 minus 1. So it's just the slope formula. That's all it is. So the rate of change is just finding me the slope in between those 2 things. And that is 950 minus that, negative, let me see, 404.2 over 2. You guys got calculators, so please move forward, right? Okay, so it's negative 120. Now, it's a rate of change, isn't it? So, as part of my answer, I have to label what it is. So it's negative 120 what? Denny? Liters per hour, right? L-A-T-T-E-R-S. Is that spelled correctly? L-I-T-T-E-R-S? Huh? 1 T. Ah. Liters, there we go. Is that 18? Seems pretty easy now that we're looking back at it, right? Okay. Next part. Use a left Riemann sum with 4 subintervals indicated by the table. Estimate the total amount of water removed from the tank during the 8 hours. Is this overestimate or underestimate of the total amount of water covered? Give a reason for your answer. So, we are going to go back to this page and we're going to draw the graph. So, we have 0. What was the next one? 1, then 3, then what goes next? 6, then 8. Okay, like that. So 1, 2, 3, 4. Yeah. All right. So we're using left hand. So Riemann sum left hand means that I am going to take the point for the left side all the time. So right here at 0, what is my value going to be at 0? Right here, there, 1340, right? Okay, good. So I, right here, 1340. Okay, what is my value at 1? Okay, so it's going to be a little bit less. Okay, my value at 3? 950? Okay, it's on the board right now. And what's the value at 6? 740. And value at 8? 700. So I am a very visual person. So I can do this without this, but this hopefully is going to help you with going through this. So this is a left hand. So I make, in Riemann sum, I make little rectangles. So in the rectangles, I'm going to start here. Right there. So the height of this one is going to be 1340. What's the width of this rectangle? Is this one right here is just 1, right? Okay, so that's going to be times 1 plus my next one, which is going to be the rectangle on the left-hand side. So I go with this dot here. This height right here is going to be 1190. And that's going to be times the width. What's the width of this one here? 2, right? Plus this one here. So this height is going to be 950. And the width on this one is 3. Plus this one, my height is right there. So my height is going to be 740 times the width, which is 2. Very good. All right, so if you could add those up for me. Put in the calculator. Did you already get it? Oh, you get it. What'd you get? 8,050? Okay. So 8,050. So that's good. And since this is, what are my units going to be on this? Remember, this is the R, right? what is the R measuring? It's still liters of water, right? Okay, so this is, since the area is going to be the total amount of water that I have there. So this is going to be, there you go, 850 liters. Now, let's go back to the question. It said, left hand, is this going to be an overestimate or an underestimate? So now I'm going to connect my dots. Since I'm connecting the dots right here, is this an overestimate or underestimate? It's over. Why? Are your rectangles above the line? Yeah, the rectangles are above the line. So in a left hand, and it's decreasing, this is going to be a overestimate. But now we could actually show in this right here that this is a overestimate given my graph. So you could actually show it like that too, to still get the points. So like I said, I'm a visual person, and by seeing it, you could actually do all this and see what it is. So I could have done it just using the table to do the math on it, but if you sketch it for yourself, especially since this is a calculator one, I could use this. So this is a overestimate. Overestimate. Okay, let's go back. Overestimate the total amount of water removed. Give a reason for the answer. So our reason is in our graph, right? We showed that. We showed, so the graph shows, so you could, if you want to, you could actually even say graph shows that this is a overestimate. Use your answer for part B. Find the estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. So we're going to use that answer from B. So first, how much water did I start with? Nope. 5,000, right? 5,000. Is it 50,000? 50? Okay. So we're starting with the 50,000. So right here, it says at time 0, we have 50,000 liters of water. So that's a good start right there. Plus, now I have water going in, don't I? Yeah, there's water going in, so I still haven't dealt with this one yet, but from 0 to 8, I still have that other equation, which is my W equation, the water going in, which is W of T, 2,000 E negative T squared over 20. Hopefully I wrote that down correctly. Negative T squared over 20. Yes, liters per hour. There we go. And this is going to be my dt. And, but then that's the water going in, but what else do I have? You have water going out, don't you? So what do you think I should do with the water going out? How about subtract it, right? Yeah, subtract it, but, and since we found it in the answer in B, that was 80/50. There we go. So, since this is a calculator portion, we're going to just plug this in the calculator to make our life a whole lot easier and a lot quicker. There we go. So start with my 50,000 plus integration
from 0 to 8, 2000 e to the negative x. It doesn't like plugging using t as a variable, so that's why I'm using x squared over 20 dx, and now it is going to be my minus, dang it, move over first, there we go, minus my 8050. Bless you. So I get 49,786, and it said round to the nearest liter. So round to the nearest liter. So that would actually be right here, just 0.6. So 49,786. Alright, so it says right there, and I labeled it with the units and explaining what it means in context. So it means that there is 49,786 liters in the tank after 8 hours. Does that make sense? Okay, so in context, you have to make sure you label it with context. Okay, so from the interval from 0 to 8, is there any time where the rate at which the water pumped into the tank is the same as the rate at the water is removed from the tank? Explain why or why not. Okay, so we are going to test. So we're going to do the tests. So what is W0 minus R of 0? So we're evaluating for both of these. So W of 0, plug in 0 to there, into my equation right here without doing, it's not the integration, I just want to find out, plug in 0 there. So that's going to give me e to the 0, which is just 1, right? So that would be 2,000 minus R of 0, which was 13 something. 1340. And then I test it at the end. So this one right here, it's greater than 0. So my whole thing is going to be greater than 0. Then W of 8 minus R of 8. So R of 8 was 700. And plug in W of 8. What is it? 81.52, right? Okay, so if you notice right here, this all here is less than 0. So over here, this is a positive, and this one is a negative. That's a G. So positive and negative here. So is there a change of sign? Since there's a change of sign, that means at some place using mean value theorem, that it's going to actually be somewhere
it's got to become 0. Because right here it is greater than 0, over here it's less than 0. At some point, because of that, that W of 0 has to equal R, not W of 0, but W of T is equal to R of T, somewhere in there. Alright, sorry for keeping you guys too late. Alright, so, bye you guys. You're taking chemistry, good luck. Okay,